This video is the introduction to Activity 2.2, the introduction to tile figure sequences. The purpose of this activity is to learn to analyze sequences of tile figures numerically in words and symbolically, to see and define and explore an underlying algebraic pattern. Also, to learn to model algebraic patterns with black tiles and end strips, and to represent the algebraic pattern graphically. We'll use black and red tiles and some new pieces, black and red end strips and black and red end strip edge pieces. We'll start by defining the black end strip. A black end strip represents a positive output number n for an input of n is 1, 2, 3, etc. The height of the black end strip is fixed and it's the same length as the edges of the black and red tiles, so 1 or -1. But the length of the black end strip is an arbitrary length. Since the strip is black, the dimensions of the black end strip are like all black arrays. They will either be 1 by n or -1 by -n. You can think of it as n black tiles. The arbitrary white space can be at the left or at the right. The orientation doesn't matter. In fact, we'll see vertical representations of these strips as well. So you can see in the diagrams that the black strip is either 1 times n or -1 times -1 when we look at the edge dimensions. It's our variable piece. A red end strip represents a negative output number. So -n for an input of n is 1, 2, 3, etc. The height of the red end strip is fixed and it's the same length as the edges of the black and red tiles, 1 or -1, but the length is an arbitrary length, just like the black strip, but negative. Since the strip is red, the dimensions of the red end strip are either 1 times -1 or -1 times n, as illustrated in the diagrams. We'll use edge pieces to measure length. In Chapter 1, we used black and red edge pieces to measure lengths of 1 unit and -1 unit. In the same way, a thin piece of a black end strip edge piece, measures the length of n units, and a thin piece of a red end strip edge piece, measures a length of -n units. End strip edge pieces, like black and red edge pieces, have no height. They're only used to measure length dimensions. So you can see the illustration there, either n units or -n units long. And of course you saw those already on the black and red end strip dimension pictures. Let's look at an example of modeling with black and red end strips. A sequence of tile figures whose nth figure, figure n, is modeled by a black or red end strip might look like one of the following horizontal or vertical sets of tile figures. The black and red end strips in these examples represent figure n in the tile figure sequences. So you can see here we have an example of horizontal black tile figures. And of course the same idea applies to red tile figures. So figure 1 is 1 black tile, figure 2 is 2 black tiles, figure 3 is 3 black tiles, and figure n is an end strip, or n black tiles is the easy way to think about it. And you can see here that we have the sizes marked as 1 by 1, 1 by 2, 1 by 3, and 1 by n, because remember it's row by column. Here's a vertical representation. In this case we have red tile figures, and of course the same idea applies to black tile figures. Our first figure is 1 red tile, our second figure is 2 red tiles, our third figure is 3 red tiles, and our nth figure is an n strip that's red, or you can think of it as n red tiles. And here The size we have listed as -1 times 1, and -2 times 1, -3 times 1, and -n times 1. Of course, those could be reversed if you think about how you would lay edges out about those tile figures. A black or a red end strip can be used as all or part of the nth figure of a tile sequence and can be combined with other algebra pieces in black and red tiles to model nth figures. To sketch these strips, you can simply sketch the rectangular outline and mark it with a B or a red. And to sketch the edge pieces, you can sketch a line and mark them with 1, -1, n, or -n units. And you can sketch with or without edge pieces. And you can see some illustrations there. When you sketch tiles for tile sequences, to sketch the black and red tiles, the shape and the exact number of the tiles really matters. So sketch clearly marked outlines labeled with B's and red and R's as needed. So you can see there's an illustration of a black tile figure, a red tile figure, and a black and red tile figure. And for this particular activity, we're only using black tiles and black end strips, but in future activities, we'll also use the red pieces. We'll continue to use our three-step pattern analysis. The three-step pattern analysis process applies to the tile figures as well as toothpick figures, as explored in Activity 2.1. And remember, Step 1 is numerical pattern analysis, Step 2 is words pattern analysis, and Step 3 is symbolic pattern analysis. Let's look at looping tile figures. We loop tile figures in the same way that we looped toothpick figures. For tile figures, for constant parts of the figure, mark the constant with the value of the tiles 1, 2, -1, -2, etc. Or you could use 1b, 2b, 1r, 2r. And for tile figures, for parts of the figures that grow, it's very useful to label the dimensions of the looped components. For example, in this sequence, the red tiles are constant. You can see each figure has 4 red tiles. That's a constant term. There's 2 on each side of each figure. The 2 red tile groups are each labeled with their values, -2 here in the picture, and in the middle, the black tile component grows, and the growing group of black tiles, they're labeled with their changing dimensions. So you can see in figure 1, that's 1 by 1, in figure 2, that's 1 by 2, in figure 3, that's 1 by 3, and in figure n, that's 1 by n. You can see that that's reflected in the count as well. So that was step 1, numerical pattern analysis. Let's do step 2, the words pattern analysis. We might describe this as -2 plus 1 times the figure number plus -2. And then for our third step, the symbolic pattern analysis, we can say that our then total, our output t is equal to -2 plus 1 times n plus -2. Which when we simplify turns into n minus 4. And if you look at figure n, you can see that that's an n strip n and 4 red tiles, -4. That's it for the introduction to Activity 2.2. I hope you have fun exploring this activity.